If we talk of reasoning in human beings, reasoning always leads to creativity. Right? Because why do we have to reason? We have to reason because reasoning is a systematic way to train your mind in such a way that if you encounter a new problem, you would envisage a new to the world solution that does not exist. Now, are machines doing it? They are not. Given that, the grand question is it a fair thing that we restrict these machines by imposing what human beings call as reasoning onto this? So we have evolved, right, to create via reasoning. Is this the only way to make these LLMs create, right, by imposing human reasoning? See, the question is the following, right? I mean, what do you mean by reasoning in intelligent systems? So now what has happened is that we thought that human species is the only species that is intelligent, so to speak. Now we'll have to now put intelligence in under code. So we thought that we are the only intelligent species. Now, we see another species, or whatever you want to call, right? Another paradigm that is emerging, which we call the artificial intelligence these days. Now, in fact, we as human beings have no idea how to deal with anything that is intelligent, because all these millennia, right, throughout the evolution, we have been dealing with things, or rather species, that are powerful otherwise, physically or otherwise, but not intelligent. Okay, now we are staring at something that is intelligent, more intelligent than us, right, and can do more cognitive tasks than we all do. Now the question is, we will have to redefine a lot of these things, and how do we deal with this sort of a situation? This is a civilizational change. Now we talk of intelligence. So first of all, there is intelligent systems, right? Had we had this debate, let's say a decade back, the topic would have been what is reasoning in human beings, right, or human intellect. Now we call them intelligent systems, which encompasses both human beings and machines, right? So now intelligent systems now not only include human beings, but it also encompasses these artificial intelligent systems, AI systems. Now the definition of reasoning has to cover both of these parts, okay, of intelligence. Now what is reasoning in human intelligence is one question, and the other important question is what is reasoning with AI systems, artificial intelligence systems. And more so, to me, the most important question would be that can we come up with a definition for reasoning that would cover both of these species, if I may use the word, and is extending the definitions of reasoning that we know for human beings a reasonable thing to do? I mean, yeah. So when I say we always say that we want to do reasonable things. So is it a reasonable thing to do to just extend the definition of reasoning in intelligence to artificial intelligence? So these are, I think, some of the important questions that one should look at, right? So now what is reasoning with intelligent system is the question. Now we have some understanding, both from Indian epistemological systemic perspective and from the Western worldview. We do understand what reasoning is. So let's think about it. Now I'm a teacher, okay. Now we always tell our students that it doesn't matter what answer you give. So when we interview people, we tell them that don't give us an answer. So what is important is your thought process. Well, why is that important? It's because as we judge fellow human beings, or we quantify the ability for intelligence through their abilities to reason through a task. So what's not for us, it's not important. And of course the end outcome is definitely important, but more than that, when we are assessing human beings, what we assess is their capability to reason. Now what is this reasoning? So now we all know about the inductive and deductive logic, right? So in deductive logic, what we do is that if we have to arrive at a particular conclusion, we would have arrived at that particular conclusion through multiple steps, multiple hops of steps. And all these hops that we take are connected to each other in a logical sense, right? So, I mean, if you want to broadly define what reasoning is, so it's actually a chain of logical steps that are interconnected, or interconnected through some predefined rules. This is one of the possible definitions of what reasoning is. Now, this develops over time for human beings because in fact, if I have to quote some of the Indian epistemological works, right, they say Vyagatavadi Rashanka, Tarkashanka Vadharmata. So the point is, you start creating that chain of logic. The chain breaks if you hit the roadblock of what is called as a contradiction. Okay, Vyaghatavadi Rashanka. So what do you mean by a contradiction then? So we assume that we all know what contradiction is, right? And we define a subset of rules which we call as contradictions, and we start creating the entire chain of logical steps, and we call that the entire graph that we built, if so to speak, as the reasoning that we have come up to arrive at this particular outcome, right? This is what we call as reasoning. In fact, in the modern machine learning terminology, right, this also has a name. This is called chain of thought reasoning, right? So what is basically chain of thought is simply a connected graph, right? So with directed edges, it's a connected graph with a lot of directed edges. The question that we are asking is, given a question and there is an answer, what is this graph what is the graph that has been internally represented that led to this particular answer, is what we call as reasoning. Now, I think this definition of reasoning, which is creating this sort of logical connected graph, is common between both the human brain and machines. Okay. Now, there are two questions here. If you now today use some of these AI tools, right? When you ask a question, there's also this tab that if you toggle that, it'll tell you show thinking, right, or show reasoning. I don't know how many of you have actually seen that. If you see that, it's basically you the edges of the graph that I just talked about, right? So there are edges of these graphs that are connected, that are being formed when this LLM is answering, and it is that graph which is exposed when you toggle that show thinking tab. Now, the important question is, how did these machines get to that state of reasoning, right? Now, to me, I can tell you the engineering answer. The engineering answer to that question is that these LLMs were force trained to create that graph. What do I mean by force training? When these LLMs were being trained, there was a lot of data that was collected a priori, where a human being was asked to expose those logical edges, right, of the graph, and they were fed as data under a reinforcement learning algorithmic paradigm, where these machines are made to forcefully mimic that particular graph when it is answering. Okay, so this is what is fashionably called as the chain of thought reasoning, or COT reasoning, and so on. Now, given this, here is an important question that I would pose with all of you, is that now what we are doing is, we think that the idea of reasoning is very innate to human beings as intelligent systems, and whatever human beings are processing and or creating the graph as this internal thinking has to be mimicked by an LLM. Now the question is that the only way that a machine can think? Now I will give you an analogy for this question. Now, as computer scientists, right, we keep asking this question. Suppose there's a neural network that is doing something. There's always this question of interpretability that comes up, which is, okay, now this neural network is doing, or this LLM AI is doing something. Tell me why it is doing what it is doing. Okay, so this question has been tackled in multiple ways. One way to do it is to look at what are called as activation maps, where maybe it's too much detail and engineering. Basically, if you look at neural network as a mathematical function, which would take some input x as an input and gives y as an output, right? So now y equal to f of x, where f is your neural network. If we have to know why this neural network is doing what it is doing, we'll have to learn how to invert that particular function. See, mathematical inversion is what I'm talking about, right? When you, instead of saying y equal to f of x, you would say x equal to f inverse of y. Okay, so given a particular output, you tell me what trigger it is. Now, inverting a compositional deep neural network is an ill-posed problem, because mathematically it can't be solved. So people came up with approximations. Now, there are lots of studies, okay, that have to show that the so-called thinking, okay, of a neural network has no correlation with the way the human beings look at it. So there are lots of these anecdotes, right? Where a neural network was built to, let's say, detect whether somebody is to look at a picture and detect whether somebody is a doctor or not, right? Profession classifier, and it was shown that it was actually putting one particular gender as doctors and the others are not. It learns some other kinds of bias. Now, these neural networks do not learn what human reasoning is. So that's why these LLMs are forced to mimic what human reasoning is. But now the question that is to be asked is, for epistemologically complex tasks that we look at, do we really have to impose human reasoning on top of LLMs? Or is there, or are we ready to live with the implicit representational reasoning that these neural networks get onto, and we are okay with whatever it is showing, right? Because when there are actually, one can argue for both the directions, right? So one is, if you can argue that one has to impose human thought process into these LLMs, because the idea of what is ethical and what is right thinking and what is wrong thinking will only come if you impose the thought process of human beings. The antithesis to this is that new discoveries, right, can only happen if you make these LLMs freeform, right? So it's like, if you impose too much of human-like thinking onto these LLMs, not sure if these LLMs can be used for coming up with ideas that are not known to human beings before. So now the grand question that is to be asked is, while we are imposing the reasoning abilities on these AIs or thought processes. So as I said, no, the central question when I thought about this topic is that we talk of limits of computation and reasoning, right? So the modern day LLMs or AI systems today are shown to scale with the computational resources, right? I mean, we have actually seen that the more you throw the compute and data to these models, the better they are getting. There doesn't seem to be saturating anywhere. Now, the limits for reasoning can come from the point that all the reasoning that these LLMs are today imbibing are the ones that we are imposing on them through the human chain of thought. So the question is it ethical, right? Or is it the only way that we need to impose our way of thinking onto these LLMs? Or should we have to try to debug or look at the inverse of what these LLMs are thinking, so that maybe LLMs will discover more patterns in its representational space that would help the humanity at large. So these are the kind of limitations and questions that one should ask. But right now, what is happening is that the all the thinking that is being imbibed onto these LLMs are subjected to what human-like thinking that we are imposing on these LLMs. Okay, I think with that thought, right, I would like to stop or pause for a while and hear your thoughts on this. Right, I mean, here is the grand question. Now, when these intelligent systems are thinking, okay, right now they are thinking the way human beings are thinking, because we have algorithmically made them to think the way we want them to think. In fact, I'll tell you something. So I was just listening to a lecture from this guy Demis Hassabis, right, who is the founder of DeepMind. This was a month back. He visited our campus, and he gave a nice anecdote, right? I mean, before the advent of all this AI, the pinnacle test for AI was this thing called Turing test. So I'm sure that all of you know what Turing test is, right? For those of you who do not know, Turing test was perceived to be the ultimatum of when you would call a system intelligent. The idea is that you make an AI system, okay, interact with a human being, and if the human being, that the fellow human being who is interacting with the system, will not be able to make up whether he or she is interacting with a machine or a human being, then the machine passes the Turing test, was the golden standard. Okay. Now that's Demis said that Turing test is passed because it's almost impossible to discern whether you are interacting with a human being or with an LLM these days, right? Today, if there is a chatbot that you are interacting with, and if it's an LLM based chatbot, it's extremely difficult to understand whether that's an LLM based chatbot or a real human being. So Turing test is passed. if that's when we are not happy with it, right? I mean, we are human beings are too greedy, so we want one other test to look at what quantify what intelligence is. And Demis said that now people are thinking of this particular test called Einstein test. Okay, so what is Einstein test? Let's say that we train an LLM or an AI machine with all the physics and all the mathematical knowledge before 1900. Okay. Now the test is that whether this LLM would hypothesize theory of relativity. Because theory of relativity was hypothesized in 1990s, 1920, right? 1990, 1920s. Now, if you feed all knowledge to that, okay, and time limit it, and ask it the question, what is the next frontier in physics? Or can it come up with it? Now, it turns out that it's not, because very recently in our lab we made an experiment. In fact, I've written a blog on that. We call this deja vu code. Okay, so the experiment that we conducted was as follows. We looked at the coding as the use case. We took an LLM, okay, that is time bound in the sense that we took an LLM that was trained, let's say, before 2025 June, okay, and then we tried to test it over some data that was created post 2025. It turns out that these LLMs cannot hypothesize what's happening in future. So they're extremely good at analysis, because that is what we have taught them to be. They're not good at synthesizing new knowledge. Now, again, I'm saying all this because I wanted to ask that grand question that now, if we talk of reasoning in human beings, reasoning always leads to creativity, right? Because why do we have to reason? We have to reason because reasoning is a systematic way to train your mind in such a way that if you encounter a new problem, you would envisage a new to the world solution that does not exist here too. Now, are machines doing it? They are not. Given that, the grand question is it a fair thing that we restrict these machines by imposing what human beings call as reasoning onto this? So we have evolved, right, to create via reasoning. Is this the only way to make these LLMs create, right, by imposing human reasoning? Is a question. Nobody has an answer to it. So I think it's an interesting way to look at it, right? It's a double-edged sword. If you do not make these LLMs to reason, they will hallucinate in the sense that they'll start giving all kinds of answers. And if you ask them why this particular answer was given, since it is not trained on human chain of thought, it would give all kinds of junk. But if you overtrain them, you would not extract everything that you need from an LLM because they are not being creative. Now that is where we stand. It's very similar to the question that we encounter as teachers daily, right? So what should be the limit of teaching? So how much information do you have to feed to a particular human being that they will not overfit into that particular small space of information and do not and stop creativity? On the other hand, if you do not regularize them, they will overfit. This is that famous bias variance trade-off problem that often comes up in machine learning, right? So if you train it too much, then it'll get stuck into explaining what already exists. If you do not train it good enough, it will not even explain what is there. So these questions of reasoning exist. And as I said, right, the idea of reasoning in Indian epistemology is well defined, that you create a set of rules and then create a logical graph based out on those rules, and every edge gets formed only if there is an epistemologically valid argument to create that particular graph. Now, do these kinds of exact reasoning capabilities being imposed on machines, is that the only way to go forward? I'm not sure. That's an open question to discuss. Right. So I think with those thoughts, I will stop here, and I would like to hear some thoughts from the audience, and what do you think about it? It's something that I would want to know. Thank you.
So my question is, so when you say the creativity has to be an integral part of a true reasoning, so is that, does that necessarily mean that we need to have a system having some kind of metacognition?
Well, yeah. So that's a meta question.
Yeah.
Yeah. See, yeah, that's a very, very good observation that you made, right? I think so. I think so because I'll tell you. See, as they say, necessity is the mother of invention, right? These traits of being curious, the traits of urge to solve a problem comes only through metacognition. See, one question that keeps coming up is, these LLMs are so powerful. Why do you think they're not taking over the world and trying to make human beings extinct? It's because they do not have this thing called Iccha. That's my way of saying it,
Yes.
right? So that is that they don't have desire, or they don't have metacognition, and that is why they're not doing anything, right? They're just our slaves until now. Oh, I think so. But see, the thing is, even with prompts, and even if you prompt them to be creative, they are not very creative today. I think that is because that we have imposed too much of reasoning on them.
I mean, the LLMs can still create very beautiful poems glorifying you, praising you, that you are such a big person. So, I mean, just anybody, just I tried it out. It praises so
I agree,
loudly.
but that's still, see, one can argue that that is still stochastic parroting, no? I mean, it's a debate. It's definitely a debate. I mean,
Yeah, I
whether
don't want to believe that they have any kind of metacognition. Yeah, it just imitates because it's trained
I
enough.
personally, I personally don't think so. So, do you know what you know and all?
Yeah, maybe.
Okay. So I just disabled my video. See, I was saying personally, if you ask me, right, do I think that these machines have metacognition? I would definitely say no. Now,
Yes, I would
that's my
also
opinion.
say. Yes.
Yeah, but I tell you why, right? What's my reasoning to believe that they don't have metacognition is for us is as follows. Now, anything that would have a metacognition would act involuntarily without being prompted,
Yes.
because that's the immediate outcome of what metacognition is, right? I mean, that's desire. See, metacognition and being ambitious and desireful are one and the same to me. So now, since they are not acting, they are not hacking your computer. I mean, even though they can, they are not hacking your computer and downloading, something, or taking your money off. Because these kinds of things are not happening, I would like to reason that they're not cognizant that they are cognizant, right? That's what I would think.
That's true. I mean, one aspect I see here is as soon as you say the aspect of metacognition, they necessarily pull in the aspect of agency also, because without agency, the
Exactly.
technology doesn't really carry any meaning. So
Exactly. And agency, the moment you talk of agency, right, that comes with desires. So which
right,
is
right.
which is which is very difficult for these machines to get into, correct?
Yeah, that's true. That's true.
Yeah.
Here there are one more question from Dr. Venkatesh.
Yeah, thank you for the intriguing talk and discussion. My question is about interpretability. So the way you framed it is, and the way it is known is why it is doing what it is doing, right? So my question is that question even relevant for AI systems as they stand today? Instead, we should ask simpler question: how it is doing what it is doing, which is answerable because of the
Actually, yeah. See, how question is more or less answered. No, as engineers, we do know how they are doing what they are doing. See, I'll give you a couple of examples of where this why question is of importance. See, I collaborate a lot with clinicians and doctors in solving variety of problems. Now, let's say that we are building an AI system to uh, delineate some tissue part in an image, okay, in a radiology image or something. Not even once doctors are happy if we give the right answer. They'll always ask us, tell me why did this arrive at this conclusion. In fact, what happens is most of the times, even if these systems arrive at this correct diagnosis, people want to know why was that particular diagnosis arrived at. Because see, an answer, I mean, if you think of it like a directed graph, right? Starting with a particular root node and getting at a particular leaf, which is a diagnosis, depends completely on the path. So now, if you have come to a particular leaf, right, and come to a particular conclusion, unless you traverse the path completely back, you're not sure why was that conclusion reached. So, as human beings, right, suppose the outcome of these LLMs turn out to be something that is unfavorable to us. See, it's like this: somebody goes to a doctor and if they get a diagnosis that is not favorable favorable to that particular person, we would always seek a second opinion, and we would more so ask them for a reason, so as to why did they get to that particular conclusion. So in cases like these and many, I can cite many more examples where the why question becomes more important than how question, right? I mean, how question is also more or less answered because we know how to make them mimic thinking. We know how to make them show their thinking, display them, and go back and all that. But now, why is a question that is more important, is what my opinion is.
Yeah, I agree with you. The how question is kind of answered, and then I mean that's an architectural question. But
Correct.
here the why question, aren't we jumping the chain of thought here? Because we know it's a stochastically it produces some outputs, right? And then you can trace back the why of a particular output was generated by looking at the weights of the model and so on. But if you're trying to impose the semantics or the structure of meaning onto why a particular output is generated, we're not going to get that answer because the meaning is already stripped off while in the architecture and in the training process. So
Why do you think?
the
Why
why
do you?
question, when we ask a doctor, that why question is very different when we are expecting a certain answer or certain path of reasoning. That's very different than asking a why to a AI system, right? So that I just felt
Why do you think? Why do you think the idea of reasoning is stripped during training? It's an
the
interesting
meaning.
perspective.
I'm saying the meaning.
Yeah. See, that is, I mean, why think of training, right? Even every machine by construction does not have this idea of meaning anyway, no? See, that is what Jyotiranjan was also asking. Then we go on to the realm of agencies and so on. There's absolutely no meaning or purpose to any of this for as far as these machines are concerned, right? So I agree with you. So on that front, and if you look at the entire thing from that perspective, then there is no way that we can ask this why question. I agree. But when you say how, right, I mean, you can also interpret this how question not from an architectural perspective, but also from reasoning perspective, right? How did you arrive at this particular answer is a question that we can ask. And that, I think, perhaps can be solved in an engineering way as well, right? Without going to the metacognition or even purpose level questions. I think they are definitely important, but at least as an engineer, I would say I would stop at getting engineering answers to a particular question. But yeah, that's a very nice observation that you made.
I think that's a good conclusion, everyone. Thank you, Dr. Pratosh, for it. I would like to thank you, Dr. Pratosh, for your valuable
Pleasure.
time and
Thanks
beautiful
for
insight.
having me. Thanks for the invite. Yeah, it's a
Very
pleasure for
interactive
me.
session. Brings a gist and zeal to the whole whole event. Thank you, sir. We
Thank
would
you.
move on